Last time we were seeing the development length equation for tension bar. This time I am showing you the development length equation for hooked bar. You know that sometimes when you design beam, if the space is limited, but I have lot of reinforcement, so sometimes we do hook. In that case, the development length for hook bar can be calculated using this equation: 102 psi e Fy dB over lambda f, square root f prime c. So everything is clear except say psi e. Psi e is the epoxy coated factor. If your bar is epoxy coated, then this factor applies. If your bar is not epoxy coated, then it is on. If it is epoxy coated, still there are two points. One is uh, if the cover or the clear is if the cover is less than 3 times the bar diameter, or the clear space is less than 6 times the bar diameter, then this factor is 1.5. Otherwise it is 1.2. If there is no epoxy, then this is on. Lambda is lightweight factor. If your concrete is lightweight, then we use this factor. Is typically 0.75 in this current specification, but it might change over time. Okay, that when you will design like later, you should always check the design specification, because any factors can change over time. Okay, and this development length per hook may not be less than 6 inch or 8 times the bar diameter. So it cannot be less than 6 inch or this. You should remember that, because if we use this equation, most of the cases it will be very small. Okay, so if I go now, uh, what is the definition of hook? Hook is doesn't mean that you will just hook the bar and it is done. No, it have some specification. So you can see here. So say if this is your point, from here to the end of the bar is called development length for hook. So if I make it small so that you can see better. So yeah, the distance is from the point of concern or critical point to the edge, the outside is called the development length per hook. Now if we use 180-degree, that means to complete a U-turn, then you must follow this specification. If it is 90 degrees, just bend like this, and this will be your radius. This will be a part of the quarter circle, and here to here must be 12 times bar diameter. If you do 180, then this will be a semicircle, half of the circle, and the radius depends on the bar number. If the bar is 3 to 8, number 3 to number 8, it should be 4 times bar diameter. 9, 10, 11, 5 times bar diameter. 14, 6 to 14 and 18, 6 times the bar diameter. That is this radius. And the extension from here to here will be 4 times bar diameter, or 2.5 inch the minimum. Now, yeah, the field laborers who work in reinforced concrete industry, so they already know this. Is most of the time they memorized it, or they provide more than this. Now, all this recommendation is the minimum. You can provide more, no problem. You can make the this circle larger, no problem. You can extend this up to this, no problem. But you cannot provide less. And most of the cases, these values, typically the laborers or the site engineers, they memorize it. Okay, so this is the development length for hook. Next, I will go to development length for comprehension. So for comprehension, a different equation applies, not the equation that we saw for tension. So for development length for comprehension, we use this equation, which is called LDC. C means compression, L means length, D means development. So similar equation is, but this or this, whatever is larger, but not less than 8 inch. For hook it was 6 inch, and for compression it is 8 inch. I think then it is clear to you that if the bar is in compression, in that case the development length must be calculated using this equation, this one and this one, whatever is larger, but may not be less than 8 inch. So I will stop here. Hopefully you understood the development equation for hook bar and comprehension bar. So in the next video I will solve some examples. Thank you.